Okay, let's start chapter 16 and look at planar kinematics of rigid bodies. The first thing I wanted to talk about is what is a rigid body. So far, we've been just looking at point masses, something that can be represented as a dot, really. It didn't matter where or what shape the object was. We just considered its center of gravity and looked at its mass. Now we're going to see how things move relative to each other, and we need to consider what's called a rigid body. So in this case, a point B is some distance away from some point A, and it's just could be a lever arm, it could be a number of things in a mechanical system, and B is always the same distance from A. It never changes. So we call this a rigid body, and A and B move together, but they may undergo different types of motion. That's what I'm going to talk about in this lecture. So the first type of motion would be if A and B both moved on some parallel path. To some A prime and B prime, and we would call this a translation. Alright, so that's our first type of motion. Well, what if instead it took some path like this? But it still didn't rotate or anything, it's still sitting upright. We would call that a curvilinear translation. Alright, so one moves in straight lines, right? The other has a curved path, but the key is there's no rotation about A or B. And these lines remain parallel to each other when looked at from our perspective. If they were not, we would have some sort of rotation. Okay, the next we're going to then talk about is rotation. And we'll get more in depth in these in a little bit. Rotation is some axes O, and every point is going to move with the same motion that sits the same distance r away. And we will have some omega and some alpha about that point O that we're going to now deal with. We know how to deal with it, but not with rigid bodies yet. But we can say all particles in the body rotate about O, except anything on the axis. So anything on the axis itself does not rotate about O. Just consider it standing still. Yes, it is turning in place, but it has no radius, and it's not going to contribute to anything like momentum or energy. Just the mass that's out here on the edge, like further away, right? It has to be some infinitesimal distance dr away from O to have some contribution. Okay, the next is, never mind, I'll redraw one. If we have another rigid body, call it AB, well, we could have the path look something like this. Where the fact that they get closer to each other means that some rotation is going undergoing place, and it moved up and down a little bit, and as a result, we're going to call that general plane motion. General plane motion. Okay, so this represents the motion of most things, and this is a translation plus rotation. So most objects have both of these things. And rigid bodies, we definitely have to consider the fact that it is not only sliding up, down, left, or right through space, but it could also be rotating, and that'll be a key for our problem solving.